Hello, my name is Luis Aguilar, and today we're going to go over the basics of pointers. Now, pointers can be a complex topic to fully understand, and many students, myself included, have had a hard time understanding pointers fully. It can be really easy to get lost. This video is going to cover the basic concepts of pointers so that you all can get a better understanding of pointers to prepare you for more advanced pointer concepts. Now, what are pointers? Right? So pointers are designed to hold memory addresses. You are able to indirectly manipulate data that are stored in other variables. A good thing to keep a note of is of the address operator, or maybe you guys can call it the AND or the ampersand, because this returns the memory address of a variable. So memory address ID certain locations in a computer's memory. So a pointer holds a memory address, correct, as we just went over. So this basically means that it can also hold the location of another piece of data. Hence, it points to a piece of data that's stored in the computer's memory. A good thing to also know is that for C++, addresses are returned in hexadecimal. So pointer variables, also known as pointers, right? So how do you create a pointer, right? It's pretty simple. So in order to define a pointer, we just use a asterisk or the star, and we can place it in front of the variable name. So in this case, we have an integer pointer called pointer, and we see that the asterisk is placed in front of the pointer. It could also be used after the variable type, so it could be integer and then star and then pointer, but either way works. This works perfectly fine as well. And then as we see here, so the asterisk indicates that the pointer is a pointer variable. The integer indicates that the pointer can hold the address of an integer variable. And this is read as pointer, the variable pointer, is a pointer to an integer. So let's talk about some good practice, right? So just like variables, it's very good to initialize pointer variables to a valid address. That is to prevent changes to another location in memory, right? So for this in C++, we can either do it as null PTR, and this will be for C++ 11, which I'm pretty sure you guys will be on, or we could also use null. And in order to declare that, we use it like this, as shown below. So integer, we create our pointer, and then we just equal it to null, or integer pointer, and we equal it to null pointer. So now let's go over to the demo. So let's showcase pointers a little bit more, shall we? We said that pointers can manipulate data that the pointer is referring to. Well, you might be asking yourself how. Well, when wanting to change data, we can only do that by using the indirection operator, which is the asterisk as we went over before, the star. When doing this, you are actually dereferencing the pointer. When dereferenced, you are now working with the value the pointer is pointing to. So let's see that in action, right? Here on pointer2.cpp, we have the same basic layout that our first file had, right? We have our integer variable x that's initialized to 25, just a random variable. We initialized our pointer variable pointer to nothing, null PTR, which is good. And now we store the address of our variable x in our pointer variable pointer, which is fine, right? So now let's use both the variable x and the pointer variable to see what value they display. So when running it, we see that variable x is outputting the value 25, which is perfectly normal, fine, everything's good. But now we see when we're outputting the value of our pointer variable, we also get the value 25. Now you guys might be wondering, well, why that is, since pointer variables can only hold the address of a variable. And we did that on line 10. Well, let's see the cout statement, right? If we point our attention to line 16, we see that we have the asterisks here. Let's go over this step by step, right? On line 10, we see that this assigns the address of the variable to the pointer. So now let's look at line 16, right? Here. We see the asterisk, the indirection operator, applied to our pointer variable. Remember, you are not working with the pointer variable itself here when the asterisk is placed on it. You are working with the item it points to, which in that case would be x, which holds the value 25, so this is perfectly normal. Now I have a small snippet here, so let's just uncomment this. Now here we see on line 19, this shows the asterisk being used again, but this is going to be used to change the data. On line 19, right here, we see that this assigns x to the item the pointer variable pointer is pointing to, which would be the x variable. So let's save this. Let's compile it. Good, no issues. And now let's run it. Now we see here pointer variable pointer, the x is now 100 and the pointer variable is now pointing to 100. So this is all working just fine. We see that we are directly changing what the pointer is pointing to, which was 25 before, and now when we run line 18, which was previously line 19, when we run this right here, this is changing the contents. Okay, in our last demo of this video, we're going to be talking about pointer variables referencing different variables. So here on our pointers3.cpp, we have, just go to right here, we have three variables that have different values, 10, 20, 30. We have our pointer variable pointer initialized to nothing, which is good, and we're just going to see out what each content holds, which is fine. And if we run this, we know it's going to be 10, 20, 30, which is fine. But what I'm more interested is what's below. So in this code right here. So let's use the pointer variable pointer to manipulate the three variables, right? So let's run through the code first. Here we see on line 19 that we are storing the memory address of x into our pointer variable pointer. And then we see on line 20 that we are going to add 100 to the value of x, and we are dereferencing the pointer. So now we are working with the value itself. We are not working with the address, right? And then we do the same for y, and we do the same for z. And then here we're going to output the new contents of these variables. So let's do that, shall we? So when we run this code, we see that at first up here, we see that x, y, and z are fine. They're the variables that they were initially given. So 10, 20, 30, which is fine. So now when we run this section of code, we see that their new values are given, right? They each have 100 added to them. So let's go through the code right here. So once again, on line 19, we are storing the memory address x into pointer. And now here we are dereferencing pointer, and we are pointing to what x is, which is 10. And then we add 100. So this would be read as 10 plus 100. So 10x plus 100 equals x is how this can be read as. Now let's go down to line 22. We are now storing the memory address of y into the pointer. Now this is dereferencing the memory address of y, and we know that y holds 20. So this could be read as y plus 100 equals y. And so 100 plus 20 would be 120, which is what we have down here. And then lastly, we are going to store the memory address of z into a pointer variable pointer. So now pointer now has a memory address of z, and it is dereferencing the memory address of z, which is holding 30, which when we add 100, so z plus 100 equals z. And we just add the value there and it'll change, and we see that happening here. So in this video, we dived into some of the basic usage of pointers. I hope this was helpful in understanding pointers at their basic level, as to help you for future usage of pointers in your classes. I want to thank you all for watching, and I hope you all have a good day.